Everyone, thanks a lot for coming to the meetup, as well as thank you Intel for hosting this meetup in such a great venue. The topic of this talk will be a very specific kind of example data analytics stack that you may think about running, where Alluxio will bring significant benefits. And so for this one, we picked Alluxio Spark and S3. But you can imagine that you can replace any of these compute frameworks as well as the storage systems with things that you've seen in the diagram. And also, this talk is loosely based off of a blog that was written. It was also posted on the Alluxio site. And this blog goes over kind of step-by-step instructions in how to deploy this stack, as well as how to run some simple examples, which you'll see the great benefits that Alluxio can bring under certain situations. And the main motivation for why I decided to give this talk at the meetup is throughout my interaction with different members in the community, one common question that I get is, hey, I heard that Baidu is using Alluxio, or I heard Qunar is using Alluxio, and they're getting really awesome and successful results. But for me, I'm just using Spark, for example. I'm using a remote object storage. How can I see kind of the same type of performance improvements or the same type of usability improvements that they've seen? And hopefully by the end of this talk, you guys will all be able to at least have a good understanding of why Alluxio brings such benefit to this data analytics stack. So first, I want to give a little bit more about me. My name's Calvin, as introduced. I'm currently working as a software engineer at Alluxio. I'm also a PMC member of the project. And I'd encourage you, if you're interested in knowing about like the latest changes in the project, as well as any Alluxio events like this meetup, you can feel free to follow me on Twitter. So let's dive into the talk. This is kind of the outline. It should be a pretty short talk, and probably the most entertaining part will be the demo at the end. But first, I'll give a kind of overview of the technology. Gene and HY have already done a great job. But I want to give a bit more motivation about some simple use cases where it's really obvious that Alluxio can help out. Next, I'll talk about some details about the particular integration of using Alluxio Spark and S3, kind of for those who want to get into the dirty details of how to get the stack actually implemented. And finally, I'll run a short demo where you guys will be able to see the clear benefits of introducing Alluxio to the stack. So again, this is the ecosystem picture. I bring it up here just so that we get a better view of what we're looking at for this talk. You can think about just pretty much your left side. You'll see that there's Spark up there and then Amazon S3 in the bottom. And that's kind of the stack that we'll be playing with for this talk. But keep in mind, you can probably replace Spark with any or even multiple of the ones up there, as well as S3 with any or multiple of the storage systems at the bottom. So first, I want to give the motivation, like, as I said, a few simple examples of why Alluxio. Why do we want to add Alluxio or something new to the stack that has been working, I would say, pretty well for the past, let's say, decade that big data has been around. So one simple example is just data sharing between jobs. And note that I said jobs here, not necessarily even frameworks. I say jobs as in, let's say a person is running Spark job 1 and he's reading data that maybe his teammate is also going to do some data analytics on. In that case, Spark by itself isn't going to be able to facilitate that data sharing, but Alluxio can. Also, the second point is in cases where your application is not completely stable, Alluxio can give a great benefit in terms of being able to save your I/O when your program needs to retry after a crash. And finally, probably something that you guys have all already seen as obvious is that it consolidates the memory usage so that different applications, they only need to have one copy of the data in memory, which is stored in Alluxio. And at the same time, those of you who are familiar with using kind of JVM-based applications know that the more memory you stick into your JVM, the less stable it will be because of possible long GC pauses. And Alluxio is a perfect solution because we store the data off heap, making it so that your application can focus on doing application things and not having to worry about managing its heap space. So let's take a look at each of these kind of high-level points in a bit more detail. So here's a pretty standard setup where you have your computation framework, Spark, and you're running some jobs. There's two jobs in this case. And the first job is working on blocks 1 and 3. And then afterwards, it says, OK, I'm done. I finished processing my part of the pipeline. I'm going to hand it off to Spark job 2, who's going to do the second part of the pipeline. Generally, what happens is it writes it back into the persistent storage, which in this case is S3 in our stack. And then the second job is then bound by this network I/O because it needs to fetch this data again from S3. If we introduce Alluxio into this picture, what you get is kind of twofold. One is the Spark applications don't need to worry about managing that those heavy blocks in their memory, meaning you can see there's no more in-memory storage for the Spark jobs. At the same time, the pipeline is streamlined because they're now exchanging this data through a memory layer, which is Alluxio, and not going through the really expensive network throughput. You can think of it as a very general sense that sending the data to S3, maybe you get a few hundred megabytes per second at the most, whereas if you're just doing an in-memory kind of data transfer, then you're probably going to get on the order of gigabytes or tens of gigabytes. So the second example that I brought up earlier was resilience during crashes. I know all of us are probably engineers, and we all take a lot of pride in writing our code, and we make sure it doesn't crash randomly. But the unfortunate kind of truth is, in production, you may see all kinds of different things that your program may not have been built to or designed around. For example, maybe there's a temporary network outage. Maybe your data is malformed, or even it's just happened that it's during peak times and sometimes the data volume is too large. In these cases, sometimes your application may crash. And if you're just running Spark, this may not be the best because at the same time, your storage that was in the Spark application will end up crashing. What this means is those blocks that you originally had now have to be kind of reread from the remote storage, which is generally a very expensive operation. So kind of as a workaround, what you can do is add Alluxio to this system. And what happens now is the Spark is still running its kind of the application logic, which could be error prone. And when Spark crashes, things are still OK because now your data is still safe in Alluxio. And Alluxio is relatively stable because it's not doing any fancy application logic. It really is just holding blocks. And Spark, of course, is going to recover just fine because we all know the computation framework is pretty fault tolerant. So it'll retry and things like that. But next time when it retries, the data will still be in Alluxio memory, meaning that you don't have to incur that really expensive I/O cost to S3 or whichever remote storage you're using. So the final point, and probably the most obvious to you guys, is just consolidating memory. Again, this is similar to the first diagram we looked at. There's two Spark jobs. This time, they're just both reading data from S3, using blocks both 1 and 3. You can think of it as maybe in the pipeline, there's a fork, and there's two separate processing strategies, or there's just happens to be two data scientists who are looking at the same set of data. If you introduce Alluxio to this picture, what you get is the consolidation of blocks 1 and 3. So now you have space, for example, to fit something like block 4 and block 5, which could be useful to other Spark tasks. And of course, you can probably think, oh, if I have too much memory, then it should be OK to just duplicate these blocks. But this is a pretty basic example with just two tasks that have overlapping data. In a real use case, maybe you'll have hundreds of blocks. Just happens that your data set size is pretty big. In this case, you're gaining pretty much half of your memory capacity in your cluster. So that's kind of the high-level motivations, like simple reasons why we would want to introduce Alluxio to the stack. Now I want to take a closer look at a particular big data stack, which is Alluxio, Spark, and S3. So I want to give a visual representation of the stack so as to motivate how far kind of the data lives from each other. On the left-hand side, we have our computation framework, or in our case, this application is Apache Spark. And what you really want to be doing often is interacting with this really fast data access layer, Alluxio memory. Here you can see that there's a lot of arrows between them, as well as the speed between them is around gigabytes per second to tens of gigabytes per second. But of course, this isn't always possible. For example, your data set may not fit in memory. So as mentioned by HY and Gene, thanks to Intel, they've developed this idea called tiered storage, where Alluxio can also help manage HDDs and SSDs. Again, you don't really want to be in this mode because this is kind of the same as reading from disk, but it's still better than going, for example, across the country to your S3 bucket or something like that. And you'll probably get speeds around hundreds of megabytes to maybe gigabytes. And then finally, the worst case scenario is when you want to get the data from your remote storage. Of course, I can't just remove S3 from this picture because it's necessary at times. There'll be a lot of times where it's your first read of the data and really the only place it's stored is S3. But you'll see that there's only one arrow there and it's only when necessary. And it's through the Alluxio design that we try to make sure we optimize so that this really expensive read is many orders of magnitudes less often than the cheaper reads from memory or from disk. So a lot of you guys may be asking, well, I have kind of an application. I don't know whether or not I want to use this stack, why I want to introduce Alluxio to the stack. And I just want to give kind of a few points where if you do see this in your application or your day-to-day big data analytics, it probably will be useful to introduce Alluxio. The first is if 2 or more jobs access the same data set. This one's pretty clear. They'll be able to share the data in memory. The second point is going back to the kind of retry logic, where if your jobs don't succeed 100% of the time, it'll probably help a lot if Alluxio is there to kind of catch the data that would otherwise be lost. A third point, which may not be that clear, is when the data set is larger than your Spark JVM. Of course, we know that there's limitations for setting the JVM size to be too large for garbage collection, but generally, if you end up storing the data off heap, you should be able to kind of maximize your utilization of memory without worrying about the garbage collection issues. Another example is if your jobs are pipelined, similar to the first case I mentioned. This way, when your jobs are pipelined, you'll be able to share the data in memory throughout that entire pipeline. And finally, and probably a more edge case, is if your resulting data doesn't really need to be persisted all the time. Basically, you can think if I'm doing data analytics, the insights I'm gathering might not be important to persist until I really found the kind of the final result that I want to present. So in this case, you'll kind of benefit from the in-memory write, which is a really big advantage over kind of having to persist that data across to HDFS or S3. So kind of with the new Alluxio versions, with new Spark versions, people may kind of be confused which ones are the best match. For S3, there's not really a version because they just have S3. I strongly recommend Alluxio 1.1. As Gene mentioned, there's a ton of improvements there. It's also the latest released version, and we've done extensive amounts of testing on this, and we definitely think that if you're running lower versions, an upgrade is recommended. For Spark, we would recommend Spark 1.61. It's the latest released version of Spark and the latest stable. And also, as a side note, when using Spark, remember to compile the Spark compatible client with Alluxio or download the Spark compatible client with Alluxio. This will kind of make your applications be able to talk through Spark to Alluxio. And as a side note, Spark 2.0 is coming out. We haven't gotten enough kind of use of Spark 2.0 to know the exact integration that we'll have with Alluxio. But as soon as we know, we'll recommend it. I don't suspect it will be much different from the current API that we recommend. So talking about APIs, we strongly recommend to use the file system API. There's several ways for Alluxio to work with Spark, but the file system one is the one that will take the minimal code change, meaning you don't need to risk changing your logic in your core application and catching certain edge conditions and things like that. I'll give you a really basic example for what it might look like in your code. So here's the original Spark code where you're accessing the data from an S3 bucket. And now is the updated code where you're accessing the data through Alluxio instead. Basically, just change the header or the scheme portion. And now, basically, I would like to give a demo quickly highlighting some common scenarios where introducing Alluxio will be extremely helpful. All right, so here I have 2 different Spark shells. So Spark Shell is a very basic program to run some basic Spark jobs. I'm going to use it for the sake of this demo, but you can imagine this could be much more complicated Spark workloads. So the first thing I did was to set the log level to info, just because we'll be able to see the timing information. So what I'm going to do is read a file through Alluxio. And right now, my Alluxio is backed by an S3 bucket. So what this means is we're going to read a file called 45 megabytes because it's 45 megabytes. And this file is currently residing in S3. So as a simple example for what someone might do with this file, let's just say we're going to count the number of lines in this file. So now I've launched the count job, and Spark is going to do its processing. And this kind of goes back to in that stack picture I showed you guys. This is the very first expensive call, getting the data from the remote storage onto Alluxio. And you'll see here we've completed the first part in about 10 seconds, and probably the second part again in 10 seconds. And so in total, it's 18 seconds. Intel has pretty good Wi-Fi. So here's kind of the more surprising portion, where you probably won't be able to do this with Spark, or I guarantee you will not be able to do this with vanilla Spark. In the second Spark shell, I'm kind of mimicking the fact that maybe there's a teammate who also wants to look at the data. And what he's going to do is he's going to take a look at the same 45 megabyte file. And when he runs this count or whatever operation he wanted to do, you would expect that he actually needs to fetch that data from remote again and put it back into his Spark process. But if you use Alluxio, you'll see that it's actually super fast, because we only try to do that really expensive operation one time. And something else that may be more surprising is, let's say these data scientists ended up finishing analyzing the data, and they're like, let's go to lunch. So they end up getting rid of their Spark terminals. And then over lunch, they talk with another colleague, and they give him a great idea. Hey, I think you should try this another analysis of the data and see what kind of insights we can gather. So then the data scientist comes back and launches this Spark program. And this time, he again, if he was using just vanilla Spark, he'll kind of have to go through that expensive process of loading all of the data from remote storage. But luckily, our data scientist is very smart. He's using Alluxio. So now when he tries to do some processing on the file again, he sees that, hey, it's very fast, and I can do my work in kind of like a 10th or a 20th of the time that it would have taken me before. So that's it for this simple demo, and thanks a lot.